You think the speed of light is just a number? 299,792,458 meters per second. Fast. Really fast. The fastest thing we know. Fine. But why is it the limit? Why can't you go faster? What stops you? And I'm not asking for the textbook answer. I'm asking what actually physically prevents you from pushing through that barrier. Because when you dig into what's really stopping you, when you peel back the layers of what Feynman and Einstein discovered, you find something so profoundly strange, so fundamentally alien to everything your senses tell you about reality, that it will shatter every assumption you have about space, time, and existence itself. The speed of light isn't just a speed. It's not just the fastest thing in the universe. It's the architecture of reality. It's woven so deeply into the fabric of space and time that going faster isn't just impossible, it's meaningless. It's like asking what's north of the North Pole. The question itself breaks down. And by the end of this, you'll understand why. But first, we need to go back, way back, to a time when nobody even knew light had a speed. Let's start simple. Things fall. Drop something, it falls down. 16 feet in the first second, to be exact. That's what Galileo measured centuries ago. Drop a ball, drop a rock, drop anything. 1 second, 16 feet. Now look up at the moon. The moon is circling the Earth, right? It's not falling down. It's staying up there, orbiting, tracing that perfect arc across the sky. But wait, is it falling? Think about it for a second. If the moon were just sitting there in space, completely still, what would happen? It would plummet straight toward Earth. Gravity would drag it down like everything else. But the moon isn't still. It's moving sideways, tangent to its orbit, racing through space. And because it's moving sideways while gravity pulls it down, it keeps missing the Earth. It falls toward us, but keeps missing. That's what an orbit really is. Continuous falling while moving sideways, fast enough to perpetually miss your target. Now here's where Isaac Newton had his stroke of genius. The moon is 240,000 miles from the center of the Earth. We're standing on the surface, about 4,000 miles from the center. So the moon is roughly 60 times farther away than we are. Newton thought, what if gravity gets weaker with distance? What if it follows an inverse square law? That means if you go twice as far away, gravity becomes 4 times weaker. 3 times as far, 9 times weaker. The square of the distance. If that's true, then at the moon's distance 60 times farther out, gravity should be 60 squared times weaker. That's 3,600 times weaker than what we feel on Earth's surface. Now, on Earth, objects fall 16 feet in 1 second. If gravity at the moon is 3,600 times weaker, then the moon should fall toward Earth by 16 feet divided by 3,600. Do the math. 16 feet divided by 3,600. That's about 1/20th of an inch per second squared. Newton calculated exactly how far the moon should fall toward Earth in 1 second if gravity follows an inverse square law, and it matched perfectly. The moon was falling at precisely the rate Newton's law predicted. This wasn't just elegant mathematics. This was a prediction. Newton took a completely independent fact, how fast things fall on Earth, and connected it to another completely independent observation, the period of the moon's orbit and its distance from Earth. Two phenomena that seemed utterly unrelated suddenly became linked by one universal law, the law of gravitation. There was no going back after this. But Newton didn't stop there. He calculated what the shape of planetary orbits should be if gravity follows an inverse square law, and he found they should be ellipses. And guess what? Planets do move in ellipses. Johannes Kepler had already measured that decades earlier, but Kepler didn't know why. Newton explained it. He got 3 discoveries for the price of 2, as it were. And then more pieces fell into place like dominoes. The tides. Why are there tides? Because the moon pulls on the Earth. But wait, if the moon just pulls the Earth toward it, there should only be one high tide per day, right? The bulge of water on the side facing the moon. But there are 2 tides per day, every 12 hours roughly. Why? Some scientists thought the Earth was pulled away from the water. Others thought the water was pulled toward the moon. Both were partially right, but neither understood the complete picture. Newton realized what was really happening. The gravitational force of the moon on the Earth and on the water is the same at the same distance. But the water on the near side is closer to the moon than the Earth's center is, so it gets pulled harder. And the water on the far side is farther from the moon than the Earth's center is, so it gets pulled less. So you get two bulges. One where the water is yanked more toward the moon. One where the water is left behind because the Earth itself is pulled more than that distant water. 2 tides per day. The Earth and moon both orbit their common center of mass, and this differential pulling creates the tidal pattern we observe. The tides were explained. The fact that there were 2 per day suddenly made perfect sense. A cascade of other phenomena became crystal clear. Why is the Earth round? Because gravity pulls everything inward equally. Why isn't it perfectly round? Because it's spinning, so the equator gets thrown outward slightly and it balances. Why are the sun and moon spherical? Same reason. Everything clicked into place. Now, as science advanced and measurements became increasingly precise, the tests of Newton's law became far more rigorous. The first careful tests involved the moons of Jupiter. By meticulously observing how they orbited over long periods, astronomers could check very carefully whether everything matched Newton's predictions. And it turned out something was off. The moons of Jupiter appeared to get sometimes 8 minutes ahead of schedule and sometimes 8 minutes behind schedule, where schedule meant the calculated values according to Newton's laws. 8 minutes. That's a massive discrepancy. Something was clearly wrong. But then someone noticed a pattern. The moons were ahead of schedule when Jupiter was close to Earth and behind schedule when Jupiter was far away. Rather odd. Ole Rømer, having confidence in the law of gravitation, came to a revolutionary conclusion. It takes light some time to travel from Jupiter's moons to Earth. And what we're seeing when we observe the moons isn't how they are now, but how they were some time ago, the time it took the light to reach us. When Jupiter is near us, it takes less time for the light to arrive. When Jupiter is farther, it takes longer. So Rømer had to correct the observations for the differences in travel time, and by measuring how much the moons appeared too early or too late, he was able to calculate the velocity of light. This was the first demonstration that light doesn't travel instantaneously. It has a speed. Think about what just happened here. We discovered the speed of light not by measuring light directly, but by having absolute confidence in the law of gravitation. When something didn't match the predictions, instead of discarding Newton's law, Rømer asked, what if light takes time to travel? And he was right. I'm highlighting this because it illustrates something profound about how science works. When a law is correct, it can be used to discover another. By trusting this law, if something seems wrong, it suggests perhaps some other phenomenon is at play. And if we hadn't known the law of gravitation, we would have taken far longer to find the speed of light because we wouldn't have known what to expect from Jupiter's satellites. This process has evolved into an avalanche of discoveries. Each new insight provides the tools for exponentially more discoveries. In this beginning, this is the start of that avalanche, which has continued for 400 years in an unbroken chain. And we're still avalanching along at incredible speed right now. But here's where things get weird. Once you know the speed of light, once you measure it precisely, you start noticing something absolutely bizarre. Light always travels at the same speed. Always. No matter who measures it. No matter how fast you're moving. Let me make this concrete, because this is where your intuition is about to betray you. You're standing still. You shine a flashlight. You measure the speed of the light coming out. 299,792,458 meters per second. Fine. Now you get on a train, a tremendously fast train, moving at, say, half the speed of light. You shine the flashlight forward in the direction the train is moving. Common sense screams that the light should now be traveling at the speed of light plus the speed of the train. Just like if you throw a ball forward from a moving train, the ball moves faster than if you threw it standing still. But that's not what happens. You measure the light. It's still traveling at 299,792,458 meters per second. Exactly the same speed. You think, okay, maybe I measured wrong. So you get the train going even faster, 90% the speed of light. You shine the flashlight forward again. You measure. Still 299,792,458 meters per second. You get frustrated. You get the train screaming along at 99.9999% the speed of light. You shine the flashlight. You measure. Still the same speed. The speed of light does not add. It doesn't combine with your speed. It's always identical, no matter how fast you're moving. This should absolutely shatter your understanding of reality. This is not how speeds work in everyday life. Speeds add. If you're on a train moving at 50 miles per hour and you walk forward at 3 miles per hour, you're moving at 53 miles per hour relative to the ground. But light doesn't do this. Light always moves at the same speed relative to you, regardless of how fast you're moving. Why? Einstein realized what was happening. And it's so strange, so violently contrary to common sense that even now, over a century later, people struggle to accept it. Time and space are not fixed. They're flexible. They bend and stretch to keep the speed of light constant. When you move faster, time slows down for you. Your clock literally ticks slower, and distances contract. The space in front of you gets compressed. These effects are real. They are not optical illusions. They're not measurement errors. They're not philosophical abstractions. Time actually slows. Space actually contracts, and the amount they change is precisely the right amount to make the speed of light come out identical for everyone. Let me say that again because this is the key to everything. The universe adjusts time and space, bends them, stretches them, compresses them to ensure that light always travels at the same speed for everyone. The speed of light is not just a speed. It's a structural constant of the universe. Space and time are arranged in such a way that this speed must be the same for all observers. Now here's where it gets even more mind-bending. If you try to accelerate something, anything with mass, to the speed of light, something very peculiar happens. The closer you get to the speed of light, the harder it becomes to go faster. It's not that you run out of fuel. It's not that your engine isn't powerful enough. It's that the object itself resists acceleration more and more intensely. We call this relativistic mass increase. As you go faster, your inertia increases. It becomes progressively harder to push you faster. And as you approach the speed of light, your inertia approaches infinity. To actually reach the speed of light, you would need infinite energy, which is physically impossible. So nothing with mass can ever reach the speed of light. Not because of some arbitrary cosmic rule, not because of engineering limitations, but because the structure of space-time itself prevents it. Light can travel at that speed because photons have no mass. Zero. Massless particles can travel at the speed of light. In fact, they must. They have no choice. They're always moving at that speed. But anything with mass can get close, very close, 99.9999% of the speed of light, but never quite there. The universe won't allow it. Now you might ask, but why? Why is the universe constructed this way? Why is there a speed limit at all? And here's the answer that's going to frustrate you. There isn't a deeper why. The speed of light isn't some speed limit arbitrarily imposed on the universe. It's a consequence of how the universe is fundamentally structured. Space and time are not separate entities. They're woven together into space-time, a four-dimensional fabric. And space-time has a geometry, a structure. And that structure has a built-in conversion factor between space and time. That conversion factor is the speed of light. It's not that light is special. It's that space-time has a maximum rate at which cause and effect can propagate. Light happens to travel at that rate because light has no mass. But the rate itself is a property of space-time, not of light. If light didn't exist, if photons had never been created, the speed limit would still be there. It's a feature of the universe itself. Here's another way to conceptualize it, and this is where Feynman's insights become crucial. In everyday life, you think of space and time as separate things. You move through space. Time passes. They're independent dimensions. But they're not. You're always moving through space-time at a constant rate. Always. But that motion is divided between space and time. If you're sitting perfectly still, all your motion is through time. You're moving into the future at maximum speed, 1 second per second. But if you start moving through space, you have to divert some of that motion away from time. You're now moving through space and time simultaneously, which means you're moving through time more slowly. The faster you move through space, the slower you move through time. And there's a maximum limit. If you could move through space at the speed of light, you would have zero motion left for time. Time would stop for you completely. This is why light doesn't experience time. From a photon's perspective, if it could have a perspective, it's emitted and absorbed in the same instant. No time passes. The universe is frozen from its reference frame. You can't go faster than light because you can't have less than zero motion through time. That's the limit. That's the wall. You can't go backwards. You can't undo cause and effect. The speed of light is the speed at which now propagates through the universe. It's the speed at which information can travel. It's the speed at which forces act. It's the maximum rate of change itself. And here's the beautiful part that validates everything. This isn't just theoretical philosophy. We've tested this over and over and over in the most rigorous ways imaginable. Particles and accelerators get accelerated to 99.9999% the speed of light. And guess what? The closer they get, the harder it becomes to accelerate them further, exactly as predicted by relativity. GPS satellites have to account for time dilation. They're moving fast relative to us, and they're in a weaker gravitational field, so time passes differently for them than for us on the ground. If we didn't correct for these relativistic effects, GPS would be off by miles within a single day. Your navigation would be useless. Muons created in the upper atmosphere by cosmic rays should decay before reaching the ground. Their lifetime is too short, barely a microsecond. But they're moving close to the speed of light, so time slows down for them. From their perspective, they live long enough to reach the ground. From our perspective, they live longer because they're moving fast. Either way you look at it, more muons reach the ground than should be possible according to classical physics, exactly as relativity predicts. It's not speculation. It's not philosophy. It's measured, tested, verified thousands of times. The speed of light being the universal limit is as well tested as anything in physics. So let's bring this all together now. Why is the speed of light the limit? Because spacetime is structured in a way that has a maximum rate of cause and effect. That rate is the speed of light. Not because light is special or magical, but because spacetime itself has this built-in conversion factor between space and time. You can't go faster because going faster would require moving backwards in time, which destroys causality. You can't have negative time. You can't undo cause and effect. The arrow of time points one direction. The speed of light is the speed at which now propagates through the universe. It's the speed at which information can travel. It's the speed at which forces act. It's the maximum rate of change in reality itself. And this process, this magnificent avalanche of discoveries, started with Newton figuring out gravity by watching the moon fall around the Earth. Then Rømer figuring out the speed of light by watching Jupiter's moons. Then Einstein realizing that the speed of light is constant for all observers and deriving the entire theory of relativity from that single insight. Then thousands upon thousands of experiments confirming it, refining it, testing it to absurd precision. Each discovery building on the last. Each new insight opening doors to exponentially more insights. That's how science works. That's the avalanche that's been accelerating for 400 years. And we're still avalanching along at high speed right now, in this very moment. The speed of light isn't just a number you memorize for a physics exam. It's the key. It's the thing that unlocks how space and time actually work at the deepest level. It's the thing that reveals the universe is far stranger, far more beautiful, and far more interconnected than we ever imagined possible. And the fact that we can understand it, that we can measure it with extraordinary precision, test it in particle accelerators and GPS satellites, use it to make predictions that come true, that's the real beauty of physics. Not comfort, not simplicity, not reassuring fairy tales. Truth, raw, tested, verifiable truth about the nature of reality itself. So the next time someone tells you the speed of light is just a cosmic speed limit, you'll know better. It's not a limit imposed on the universe. It's the universe revealing its deepest structure to anyone willing to look closely enough. And that structure, that fundamental architecture of space-time, is what prevents anything from going faster. Not arbitrary rules, not engineering problems, the very fabric of existence itself. Now you understand what Feynman and Einstein uncovered. Now you see why it collapses everything you thought you knew. Because reality isn't what your senses tell you. Reality is what the mathematics reveals when you dare to follow it wherever it leads.